uh, to start our session. Hello, everyone. Good evening to all, dear authors and invited guests. Welcome to Technical Session 2C. Myself, Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Conference on Smart Trends in Computing and Communications through Zoom. I hope you will enjoy the knowledgeable and interactive session throughout the day. There's a special note for the presenters that you may all please stay connected with us till the closing remarks. And if you have any query or any update, you can write it to me in the chat box. Further, in this session, we have 8 presentations. Each presentation will be given 8 minutes for the presentation and 2 minutes for the question and answer. And on the 7th minute, I will raise a gentle reminder to conclude your presentation. Okay, just before we get started, I would like to invite our session chair for chairing this session. Professor Gitanjali R. Shinde. Dr. Gitanjali Shinde has overall 15 years of teaching experience. She is presently working as an associate professor in Department of Computer Engineering and at Vishwakarma Institute of Information Technology, Pune, India. She has presented a research article in World Wireless Research Forum meeting, Beijing, China. She has published 50 plus papers in national and international conferences and journals. She is the author and editor of 10 plus books. And on top of that, her book, Data Analytics for Pandemics, a COVID-19 Case Study, is awarded as an outstanding book of year 2022.
Thank you, Harsh, for a nice introduction.
Thank you,
and welcome all participants for the session.
Okay, for moving to our first presenter. Our first presenter is Prasanna, and he is presenting on a study on kidney segmentation techniques using DNA models. Dear presenter, you may please start your presentation. I think so, he's not here. Okay, so moving for our next presenter. Devendra Kumar Jail, and he's presenting on an optimized textual document categorization based on past Fourier transformation. Think so, he's also not here. Okay, so Kranti is here. I think so. No, he's not also. Okay, so moving for next presenter. Aditi Sharma, and she's presenting on a classification of bacterial skin disease images using modified convolutional neural network.
Yes, sir, I'm present.
Yes, ma'am. Please present.
Okay, so I'll share my screen now.
Yes, ma'am.
I hope my screen is visible now.
Yes, ma'am, it is visible.
Okay, so hello everyone. Myself Aditi Sharma. I am a research scholar in SRM University, Delhi NCR campus. Today I will be presenting my paper on classification of bacterial skin disease image using convolutional neural network. These are the content that are discussed in this presentation. We'll have a brief introduction about my paper, then the research question, then what the literature survey I have done, methods and data collection, and finally the conclusion. So let's move on to the introduction. In introduction, I would like to tell you that in the human body, string is the strongest barrier, which is protecting the critical organs. Skin protect all our critical organs and it provide our inner organs, it protect from damage. But there are several kind of diseases which body can experience through skin. These diseases can be bacterial type of diseases. These diseases can be fungi, virus, or even dust. So the proper diagnosis of disease is very crucial for the medication and treatment. So classification of it I will be doing in this paper will be classification into which kind of infection is this, whether it is a bacterial infection or other, it is important. In this study, I have worked on convolutional neural network, which is used to detect the skin disease. I have made a image classification model in which I have involved image classification and segmentation. I have also taken the comparative study by using two different models which are used in this research, such as VGG16 and VGG19. Although this article only uses the single layer CNN model. The research question is that skin disease detection, it always depends upon the good classification of its type. If the classification is not good enough, it is not done correctly, then it can lead to the wrong medication, and lately other ill effects will also can worsen the condition. So in this study, I have making the small classification where images are classified whether they are bacterial skin disease images or not. This study will further be elaborated in the broad classification of in which I will be classifying which type of bacterial skin disease is present in the image, so that much more proper medication can be provided for the disease. These are the literature survey which I have done. In this, I have studied all the different type of CNN algorithms which are being implemented on the skin disease. Likely in the first article which I have studied, it is based on different CNN algorithm for face skin disease classification. It includes the methodology of ResNet 50, Inception V3, DenseNet 121, and etc. It works on better performance and precision. And the limitation was that overall performance need to be improved. Then the second one was machine learning algorithm, which is based on skin disease detection. In this, it is a comparative study and comparison between the performance metrics. The methodology which are being used here are random forest, naive-based logistic regression, kernel SVM, which is support vector machine, and CNN. It works on various parameters like confusion matrix, training accuracy, malignancy, which is calculated. The limitations are the performance issues. Some are giving better performance on some parameters, other are giving better performance on other. Not any one of the algorithm is giving performance, good performance on all the parameters. Next, I have studied the paper, a method of skin disease detection using image processing and machine learning. In this, it is a pre-trained CNN, which is known as AlexNet and SVM. It provides very fast result, but the equipment which are used here are very costly. So that is why it does not act good. So moreover, the limitation over there here is that it works on a very small data set. Next paper which I have studied is also based on CNN, that is GPCNN detail. It stands for Global Part Convolutional Neural Network Model with data transformed ensemble learning for skin lesion classification. It works on enhancing the classification performance, and the limitations are that it can be used only for particular class of images. Next, I have studied self-supervised topology clustering network, which is used for unlabeled skin lesion classification. It works on improving the annotated image data, but the limitation over here in this paper comes out to be that we need an algorithm to supervise first. Nextly, I have studied the paper classification of skin disease using deep learning neural network with MobileNet V2 and LSTM. In this, the methodology that was used was deep learning machine neural network with MobileNet V2 and LSTM. It works on complex pattern accuracy and precise prediction. The limitation over here is no self-learning capability and knowledge acquisition from previous experiences. So these are the papers which I have studied before implementing this paper. The methods and the data collection. The performance measures which I have taken over here for VGG16 are accuracy, which comes out to be 95.2%, specificity, which comes out to be 95.8%, and sensitivity, which comes out to be 93.7%. VGG19 have same result with accuracy of 94.6%, specificity of 95.4 and sensitivity of 97.2. While in case of CNN, convolutional neural network, single layer, which I have used for implementing this research paper, the sensitivity come out to be 96.3, the specificity come out to be 97.6, and accuracy was 96.5. I have made a data set named testbed, which is taken from openly available data from Kaggle DermNet images. The data set consists of 23 categories of images and near about 19,500 images, which can be segregated into distinguished classes such as acne, melanoma, eczema, seborrheic keratosis, tinea, etc. Further, the data set is segregated for acne and eczema, which is categorized as bacterial and fungal infection, and I have taken that for bacterial infection. The method which I have followed is that this research technique begin with when we take the input of an image into CNN model, then we process it to produce the classification result with momentum optimization algorithm, and it is integrated with gradient descent. Since we have used only single layer of CNN, we have used 10K cross validation for categorization and classification to provide the accurate result. The modified model use only single convolutional layer with 10K cross validation. This picture represent how we have taken the image, how pre-processing is done, then what we have done is segmentation, then feature extraction, and finally we have applied classification to find out whether it is a bacterial disease, then the medicine prescription. If not, then no disease is provided, though no medical prescription is provided. These are the results which are based on the architecture of my proposed model VGG19 and VGG16 on the basis of parameters like accuracy, specificity, sensitivity. And we have also mentioned the number of layers we have used in each of the model. Like in proposed model, we have taken single, VGG19 we have taken 47, VGG16 we have taken 41. According to the test finding, CNN single layer is much more accurate than VGG16 and VGG19. The examination was finished to classify images of DermNet disease with 3 channels and JPEG format. Thank you.
It was nice presentation.
Thank you,
My
ma'am.
question is that how much images there were in your data set, and what pre-processing things you need to do before applying the neural network models?
Ma'am, as I told, I have taken the data set from Kaggle and it contained the total images of 19,537 images. And it contained various diseases like acne, melanoma, eczema. From that, I have taken the bacterial part of images and some images for training of non-bacterial part. So that comes out to be 7,800 images in about. And for pre-processing, I have applied methods like scaling and noise reduction, etc.
Okay, you have used the pre-trained models. So can you
Sorry,
tell
ma'am?
me what you have used already pre-trained models?
Yes, ma'am.
So can you tell me what is your contribution in research point of view? Like already they are pre-trained. So what should be the weight at the which layer
Ma'am,
for
my
neurons? That is already
contribution
decided.
is, yeah,
Yes.
ma'am, this model is already present, but my contribution is towards the medical field of it. That I have seen in all the researches right now that there is no such classification for skin diseases. And nowadays, there are so many different kinds of skin diseases that occur due to bacteria or fungi, which are looking exactly like same likewise. So if proper classification is not done, then in that case, it will give wrong prescription and wrong medication can further give the ill effects of it. So this is just the starting of my research. In future, I will be working on further classification where it will categorize the bacterial skin diseases into 7 types. Whatever 7 types are present there, like eczema, acne, melanoma, and tinea, etc. And then I will be working on fungal disease, where it will be classifying it into 4 fungal skin disease. And finally, it will be a combination where we will just give the data set, and it will find out what is the kind of image is having, whether it is a bacterial skin disease or it is a fungal skin disease, and which kind of skin disease is it having.
Good. So, and the last question is that, have you thought of the black box, like neural network is already giving based on some features? So have you thought on that, because of these features, these values, we are getting that this is the disease. So have you given thought on this?
Ma'am, I haven't thought about it, but yes, you have given it to me. I have noted it down and I will work on it.
Okay, that's it from my side. Audience, do you have any question?
So I think there is no question for a presenter.
Thank you so
Thank you.
much. I want to thank SMARTCOM for giving me this opportunity for publishing my paper for this research work. And I want to thank especially Gitanjali ma'am for making me enhancing towards black box testing. And I will preferably definitely work on it. Thank you, Harsh. Thank you, Gitanjali ma'am. Thank you so much.
Thank you. All the best to you. Thank you.
Thank you. Thank you, ma'am, for your great presentation. Now I'd like to invite our next presenter, Prasanna, and he's presenting on a study on kidney segmentation techniques using DNA models.
Hello, sir.
Yes, sir.
Yes.
You may please start your presentation, as we have running out of time. I hope all the participants will follow the timeline.
So is the screen visible?
Yes, sir, it is visible.
Yes. So good evening, everyone. My name is Prasanna. So today I am presenting the paper named title, A Study on Kidney Segmentation Techniques Using DNA Models. So the outline of my project includes, like, firstly introduce the project, then what motivation of my project, then the conventional segmentation techniques for the kidney segmentation, then the unit-based segmentation techniques, summary, and the conclusions. So the introduction, like, as we know, in the today's world, the kidney stone disease has become one of the most common disease in everyone. There are numerous imaging techniques for this treatment and diagnosis of kidney stones, but the CT scanning is one of the most effective technique. So this till the early 2000s, the detection of kidney stones was carried out physically by the doctors using the CT scans of the CT scan images of the patients, but it seems to be like very time consuming and cumbersome. So deep learning has emerged in this 2000 in the last decade. So deep learning can perform well when it is provided with the 3D images of like CT scan images and MRI images. So it can perform well on these images and can give a better accuracy and better results. So image segmentation can be referred as one of the crucial step in the digital processing of the image, as it divides or it decomposes the image into a number of pixels, where the grouping of similar pixels can be done so as to represent the image in more simpler way, which can be analyzed for our processing. So in that image segmentation, like UNet was one of the most commonly used model for the image segmentation task. Then what motivated me to take this research project was, like, majority of the people who developed these kidney stones at the earlier stages, they do not recognize this condition, but at the later stages it becomes one of the most dangerous disease. So like currently at some places the kidney stones the medical images of this kidney are still manually identified by the CT scans by physically by the doctor. So this can be like more dangerous and like time consuming. So why not use this deep learning and machine learning techniques to segment these kidney stones and detect these kidney stones very accurately and efficiently by the deep learning models, and develop a automated kidney segmentation technique which can make the doctor's job easy. So when it comes to the image segmentation, there are mainly two approaches. Like one is the semantic segmentation and another one is instance segmentation. The first semantic segmentation can be referred to as a process like all the objects of the same class like are represented using a same segmentation, they can be represented using the same, they are represented as same object. Like here in this example, we can see that like all the liver metastases are represented using the same color. This is a semantic segmentation, whereas the instance segmentation refers to as every instance of this same object are represented using a different object, are presented as a different objects in this image. So this can be two approaches in this image segmentation. Then it comes to the conventional methods which were used for the image segmentation. The first approach which we did a survey was like threshold based segmentation. As the name represents the threshold, like we set up a threshold for segmenting an image. Like threshold segmentation is one of the most simplest method of image segmentation, where it can be used to produce a binary or multicolor image based on a threshold value set for that image. In this process, we take into account that or a threshold or like intensity histogram of all the pixels in the image, and we set a threshold to partition this image into sectors. Like we can segment this image into like different pixels, and we can segment the image into different sectors. But the main advantages of this threshold segmentation was like calculations were simple and computationally inexpensive, but it was highly sensitive to noise. Then the next approach which we did a survey was like edge-based segmentation, which mainly relies on the identification of edges for segmentation. Firstly, edge is like edge. We identify the edge which acts as a boundary, which divides the two distinct, it divides the picture into different sections, and then it segments the image into different sectors. It is also a good and high-level method for event segmentation, but it requires high memory requirements. Then the third method was region-based segmentation. Like as the name suggests, it divides an image into different regions based on some predetermined rules. Like it has some predetermined rules to combine the similar pixel sectors into one sector, and it divides based on the regions. It works on the homogeneity principle, like the pixels, all the neighbor pixels which belong to similar properties are grouped to one sector, and other pixels to other sector. This approach has the ability of correctly separating areas into identical characteristics, but these methods are computationally expensive and noise sensitive, like it takes so much time and time consuming. So as these conventional methods were like not up to the mark, so the unit was designed for the image segmentation, primarily for the image segmentation. So first, like base unit was one of the first unit architecture which was designed mainly for the image segmentation task. The unit name comes from like it is a U-shaped network. Like it mainly, the main novelty lies is like it has both the contraction and expansion path, where the contraction does the downsampling of the image, and then the expansion does the upsampling of the image. Like the downsampling mainly refers to the, like it mainly identifies what is present in that image, and the upsampling represents where it is present in the image. Like for our study for kidney stone segmentation, in the image of a CT scan, this contraction path can tell us what is present in that image, like kidney is present in this image. Like then using this expansion path, we can locate where that kidney stone is present in that kidney. So this can be a very useful model for our kidney segmentation. So it has mainly the contraction path mainly has a typical CNN architecture, 3x3 convolutions, ReLU activation, and max pooling, which is a typical CNN architecture. But the expansion path has a same like 2x2 convolution, but it has it receives the feature map from this corresponding contraction path, and it concatenates and cropped, and it is concatenated into this upsampling feature map, so that it does not lose this information, and it can efficiently segment the image. It has advantage, like it has a advantage of faster training than other conventional models due to the context-based learning, but it also it needs a significant GPU memory footprint. So based on the drawbacks of the base unit, the residual unit was designed like this. Variety of unit was mainly motivated based on the ResNet architecture. Like ResNet was a backbone architecture for this residual unit. Like when it comes to the deep neural architecture networks, it has number of layers, and when the number of layers increase, it can converge faster to the solution, but it can lead to a vanishing gradient problem. Like it can lose some of the gradients in this process of optimization. So this ResNet solves this problem by utilizing skip connections, where it takes the feature map from the input layer and it again adds it to the output layer, so that some of the gradients which were lost can be incorporated and it can efficiently not lose any of the information. So this was one of the idea behind the residual unit for segmentation. But this residual unit had also some of the like disadvantages, like it does not completely eliminate the problem of initial gradients. Like some of the gradients used to be lost. So dense unit was like a better approach than residual unit, which replaced the residual unit residual ResNet backbone architecture by DenseNet architecture, where this DenseNet was a it's a deep learning architecture which is built upon the ResNet with two key changes. Firstly, every layer in the block receives the identity map from all its preceding layers, where in the residual unit it only used to receive the information from only the input layer. Here it receives the information from all the preceding layers, so that any of the information is not lost. And the second major changes was it was combined using the channel wise concatenation into tensors, like it used to convert into tensors, and it used to sum up and it was doing a element wise addition. So this was one of the main advantage as compared to the residual unit. It results in higher accuracy with fewer computations with a great number of layers. And the finally last architecture which we did a survey was Unit++, which is one of the most powerful form as compared to all the other unit models. It was inspired from the DenseNet, where it had the skip connections as an intermediate grid, where it used to propagate more semantical information between the two parts, enabling it to segment images more accurately, where it used to receive all the feature maps from all the previous units of the same level, as well as an unsampled feature map from its intermediate lower level. So here the upsampling and downsampling, which used to receive skip connections from all the previous layers, so that no information is lost, and it was one of the most efficient as compared to all the architectures. So they mainly addressed two major unit challenges, like unknown depth of the best architecture. So what was a best depth for a best what would be the best depth for the best architecture, unit architecture, and constraint of the skip connection, like where all the skip connections should be introduced, or where all the skip connections should be designed, so that it does not lose any of this information for the segmentation purpose. So based on this survey, we did a final summary, like what was the main main logic or methodology behind all this
Interrupt you, sir, but you have last 1 minute.
Yes, this was the main summary. Like a threshold-based segmentation used to choose the appropriate threshold for segmentation. The edge-based segmentation mainly relied on the identification of edges for this segmentation. Region-based segmentation was like a grouping of similar pixels into regions. And then the base unit, which used the combination of contraction and expansion for like upsampling and downsampling. Residual unit, which is an extension of unit with a ResNet as a backbone architecture. The DenseNet, which is used the DenseNet as a backbone, which preserved the identity maps from all the prior layers. And lastly, the Unit++, which was one of the powerful unit architecture, which used the skip connections as an intermediate grid. So the main conclusions of the project was like we aim to give the researchers a place to begin their exploration about various segmentation techniques, like who all researchers want to do various research on segmentation techniques. So our research can give them a better approach for starting up the kidney segmentation. And based on our survey, we were informed that like Unit++ one of the most powerful and sophisticated version of unit, which was a successful method for biomedical image segmentation. These were some of the references which we for survey. Thank you.
I can say it is the good survey. And with the conclusion, I just want to know that as from your survey, I could understand that Unit++ is the powerful among all the segmentation models. My question is that the power comes with some constraint, isn't it? Like it may require the computation capability or some other constraint must be there. So what are the constraints or Unit++? And the second question is that in which applications I should go for Unit++, and like some type of applications where we can work with only unit, you don't need to go for Unit++. So can you
Yes,
give a thought about it?
like unit plus plus, as I mentioned, it was one of the powerful technique based on, because it was mainly inspired from the dense net, which was one of the powerful tool. Like it used the dense net blocks instead of like regular blocks, which used the identity map, which is the main logic, like main strength of the dense net. So this identity map plus the skip connections from the previous layers, which gave us which gave this unit plus plus a more strength for a segmentation. But as you told, like unit plus plus can be can't be used in various situations. Like it can be used in the situations like when there are like more number of images, like when there are like thousands of images. So this unit plus plus can give a better accuracy when number of images increase, and when we want a better accuracy and better computation efficiency.
Okay, that's it from my side. Any questions from audience?
Okay, so I think so there is no question for the presenter. Thank you, Prasanna, for your great presentation.
Thank you, sir. I would like to thank SMARTCOM for accepting my paper and for giving me the like opportunity to present a paper in this presentation. Thank you.
We're moving for our next presentation. Riya Puri, and she's presenting on near real-time crime detection using intelligent drone capture and CNNs.
Good evening. Am I audible?
Yes, ma'am, you are audible.
Is my screen visible?
Yes, it is.
All right. Good evening to one and all present here. Thank you for the introduction, Mr. Harsh. I am Riya Puri from PS University, Bangalore, and I'll be presenting my paper on behalf of my co-authors about near real-time crime detection using intelligent drone capture and convolutional neural networks. So this is the basic outline of the presentation, which you'll see later. Okay. So crime is prevalent in our society today and can have a significant impact on the growth of a country, both in terms of economic and social development. 50 to 60% of the crimes go unreported, and most of the times there's no evidence to apprehend the criminal. Imagine a system where crimes are detected and reported in real time, no longer relying on witnesses or traditional surveillance methods. Today, I'm going to show you the combination of intelligent drone capture and convolutional neural networks and how they can detect crime in near real time, making our streets safer and our communities more secure. So this is a literature review of a few research papers that we had viewed. And there was extensive research conducted for the purpose of this project. Existing technology found in these individual modules was integrated to create a promising solution to face crime. Coming to surveillance drones, we required a high competency drone, which is programmable and can capture at least 720p in 60 frames per second to stream to a backend server or a specified port number. This model needs to be cost effective and efficient enough to implement a swarm of commodity drones, which would be our future scope. So given these prerequisites, we decided to choose the DJI Tello drone. Facial recognition, in most of the recognition models, they are based on image processing concepts to match live images with the existing trained images of the person in search. So based on the video feed from each camera, if a particular person in search is found in a certain feed, then the location and the details of the person are passed to the server. And to do this, to accomplish this, we found that OpenCV, a Python library, was the best technology that we could use. Coming to convolutional neural networks, several neural networks were researched for the purpose of this project. One such model being the VGT neural network, which is a binary classifying neural network. This model was overfitting for our particular data set and hence could not be further pursued. Another paper deeply spoke about a tube proposal network, which is a unified deep network to build an end-to-end 3D convolutional neural network for action detection and segmentation in videos. However, the vanishing gradient problem persisted, and it could only be solved using the DenseNet 121, which provided a high accuracy of 92% in the consulting research paper, and hence became the most suitable model for this proposed framework. So coming to the proposed methodology, I'd like you to pay attention on the diagram on the right. So real-time input capture, the current framework for the crime detection technology begins by launching the drone controller program. The drone API uses Python libraries such as Pygame modules to control and interact with the drone more efficiently, and captures images to be passed through to the facial recognition module here. So pre-processing on the drone was done and decided which frames will be sent to the CNN. We decided to send every 10th frame that was recorded to the CNN, and the size and the resolution of the images to fit the requirements of the CNN. For our particular DenseNet, it was a 64 by 64 image that had to be sent to the CNN. This pre-processing would also use to stream the footage to a specified port number or IP address. Then coming to the facial recognition module, the images captured by the drone were also pre-processed on the drone itself, using the Python library OpenCV for facial recognition. The model runs in coordination with the database containing images of criminals or missing persons, and on the event of a match, the authorities are alerted to inform them. This may help in applications of crime prediction as well, as we can provide an indication of suspicious activity that is going to happen. So these selected frames are further sent to the CNN or our server, and the data is passed through the standard CNN layers such as the convolutional layer, the pooling layer, and the transitional layer, which is something specific to the DenseNet. This report, if on the event of a crime, there's a crime report generated, and that contains the coordinates of where the crime occurred and the category or severity of the crime committed. This was then sent to the police or law enforcement agencies using a third messaging app. We use something called Twilio, and the law enforcement agencies are informed. Talking more about the DenseNet or the CNN that we have used, this differs from traditional CNN architecture in a way that it connects its layers. Unlike traditional CNNs, where each layer receives input only from the previous layer and passes output to the next layer, the DenseNet connects each layer to every other layer in a feed-forward fashion, as you can see in the diagram displayed on the right. This creates a dense connectivity pattern between the layers, and hence the name DenseNet. This architecture has helped us mitigate the vanishing gradients problem, which occurs in deep neural networks by allowing the gradients to flow through multiple paths in the network. Additionally, it also uses a technique called transition layers to reduce the number of feature maps and parameters in the model to control the growth of the network. This helps us prevent overfitting and makes the model more computationally efficient. Overall, this architecture is designed to handle large number of features. This was helpful to us as we had 14 different categories of crime, and also helped us reduce the number of parameters in the model while addressing the vanishing gradients problem commonly occurred in deep neural networks. So as ours is a product-based paper, there is a small demonstration. If you pay attention to the bottom left, you will notice that the running model detects crime. Now, for the purpose of demonstrating this working model, we had to create our own crime data set because we could not demonstrate violent crimes such as homicides, arsons, etc. So there was 2 GB of data, which is approximately 120 minutes, that's manually recorded to portray stealing, abuse, and other petty crimes using the drone. And now why did we do this is because most of the sources of data were stationary, such as CCTV cameras, etc. Our data set only contained violent crimes, and we did this for a better accuracy of the model. Coming to results and discussion, we used a UCF crime data set, which is a 12 GB data set containing 14 different categories of crime, as you can see in the x-axis of this graph. There was an 80:20 data split ratio between the training and the test set. Additionally, we created our own data set of aerial footage, as I said earlier, to improve the accuracy and reduce false negatives in classification. As shown in the images, the working model can finally be controlled to stream data and from the drone and identify faces which are contained in a pre-stored database. Looking at the bottom left figure, we use a multi-class AUC curve to more accurately understand the efficiency of our model and the percentage of false positives that we received. Although our model gives a great accuracy for violent crimes, non-violent crimes or petty crimes are often not detected, providing it as a limitation in this project. Finally, the AUC score for this model helped us achieve an 82.7% accuracy for this model. Concluding my presentation, the results in the tables show that the proposed model can detect crime with high accuracy and in near real time with a maximum latency of up to 30 to 40 seconds, which is why we call it near real time. The integration of facial recognition technology provides applications for crime prediction, which allows us to identify suspects, making it easier for authorities to track and apprehend them. The use of drones in crime detection increases the coverage area, but also reduces the cost of deployment and maintenance. Overall, this paper presents a promising solution for crime detection that utilizes the latest technology to improve the safety and security of our society. Coming to the future scope, some of our edge computing algorithms used in the project were not able to provide the best results in terms of latency. This drone is not able to detect the actions when the distance between the drone and the object becomes greater than 80 meters, which provides a limitation in crime detection. Another thing, coming to complex facial detection, the detection of faces is not accurate through the side angles, and to implement more accurate facial recognition and tracking objects or weapons such as guns, etc., we can use more complex libraries such as HAR cascades or a framework called YOLO, which means you only look once. For another future scope, to reduce the latency, we can use ML pipelines such as MediaPipe, which is a Google AI, to pre-process the data and create a pipeline figure of the perpetrator for action detection. To cover more heinous crimes, we want to implement a swarm of drones which could provide better results. Intelligent drone networks learn from each other and could form more cohesive algorithms to detect crimes, which could easily be a scope of improvement in our current application. These are some of the reference for the research papers that we researched for this project. Thank you.
It was a nice presentation. Can you go to the conclusion side? Yeah, so here you have given drone to backend, that the time is given. So after that, as soon as drone is going to capture the images, that images is going to be sent to the backend. And in that backend, it might possible few images are not required for further processing. So to check out which frame we need to take it for further processing, is that time you have calculated?
Yes, ma'am. So we only used a very simple algorithm, which was every 10th frame was taken from the drone and the rest was not streamed at all. So because the edge computing algorithm was so simple, it didn't provide a noticeable latency. But if we were to increase the complexity of the algorithm, then there would be a noticeable amount of latency, which we have not explored yet.
Okay. And that drone, how much degree of coverage it is taking?
So the drone flies for about 12 to 13 minutes using the current battery that it has, and it can fly up to 150 meters above ground level.
Okay, and in future scope, you are thinking about media pipe. Then is it possible that from media pipe you can check it out for multiple persons, because it works only for a single person as of now?
Yes, ma'am. Right now, it's only for a single person. We wanted to implement media pipe, but media pipe, the output is in terms of 3D coordinates. And this was not suiting our CNN, since CNN is trained using images. So for media pipe, we want to implement it as a pre-processing technique where we can see, like, if there is a crowd of people, it can detect the different pipelines of each body and detect the actions, like if they are beating someone up, if someone's being beaten up, or if they're running or something like that. But yes, that would be a future scope.
Yeah, you can also think about open pose. That is also, I think that is going to cover the multiple persons. So you can check it out for open pose as well. So it was very well presented. All the best to you.
Thank you so much, ma'am. I'd like to thank SMARTCOM for allowing me to present this paper at this prestigious conference. Thank you, Mr. Harsh, for the introduction, and Ms. Gitanjali for your valuable feedback. Thank you so much.
Thank you, Ria, for your great presentation. Now I would like to invite our next presenter, Hardik Kumar Jaiswal, and he's presenting on plant disease detection and classification using machine learning, deep learning, and spectroscopy. Dear presenter, you may please start your presentation.
Yes, sir. Is it my screen is visible?
Yes, it is visible.
It is, first of all, I would like to introduce myself, Hardik Jaiswal, and I would like to thank to SMARTCOM and entire fraternity to provide this as platform to my research. My topic name is the plant disease detection and classification using MLDL and spectroscopy. These are my outline which I'm going to cover in my presentation, that is regarding the introduction, motivation, problem statement, literature review, and result and discussion. These are the list of abbreviation which I have for my presentation. Let me first of all starting regarding the introduction of plant diseases. Plant it is like classified among the different categories according to their shape, textures, and structure, and then symptoms and the diseases of a plant that will be varied according to the environment situation. Mainly, plant diseases are classified into three major categories, that is fungal, bacterial, and viral diseases. We will just have a quick look on each of the diseases and symptoms. Fungal diseases because of the fungi, and it mostly found on the vegetables, and the major fungal diseases are found on the vegetables. They are the anthracnose, mildews, whether it is the powder mildew or the downy mildew, and the rot also. These are some examples of the bacterial disease, that is the fungal diseases. Now we come to the bacterial diseases. Bacterial name as the bacteria causes the different kinds of symptoms that including the overgrowth in the plant, and it is like near about the similar properties of the bacterial diseases, same as the fungal disease also. And we may identify the bacterial disease according to their spot, whether it's a black spot or the brown spot. And the major so one of the main dangerous diseases, it's known as the virus disease. It's difficult to analyze and identify also. And some of the examples of the virus diseases are the toboic mosaic virus, tomato spotted virus, potato virus, etc. These are the types of diseases which are found from the different papers. They are the downy mildew, the anthracnose, then the leaf blight, common rust, greening, scrub, whitefly, etc. It's my motivation to carry out this work is every year, if you will say that then because of the plant diseases, the farmers are facing the huge problems, and because of that, it affect to the country's GDP also. So I wish to be identify the disease at the earlier stages, and the classification according to the accuracy, it will be give a benefit to the society. The problem statement is traditional algorithms are working, but they are having the limited accuracy, and they are not able to properly classify the diseases. So these are the research issues which are listed from the papers. In the main issues are classification, accuracy, when we capture the image or when we will take the database, uneven background, noise removal, reliability. These are the effect to the plant diseases. So I applied the one of the innovative approach that is named as the spectroscopy. Spectroscopy is basically idea regarding the the interaction between matter and electromagnetic radiation. So we will simplify in the word that is when we throw some signals on the object and what we receive in the form of reflection, that is the spectroscopy. This figure shows how spectroscopy works. These are the frequency and its wavelength range. And these are the electromagnetic spectrum. They have the 300 nanometer to the 1000 nanometer. We are working with the near about the 400 to 500 nanometers. I will working on the specific species, that is a papaya, and I have identified the leaf curl, mosaic, and powder mildew diseases. In my university, there is a space center. I have applied for the grant and university assigned me a grant. With the grant, I have purchased one spectrometer which I ordered from the Japan, and with this instrument, I have captured the data, and I have collected the database from the Anand Agriculture University, and I have take care of the samples also. So it is like it's packaged into the plastic container, tight plastic container. So moisture and other factor will not affect to the data sample. And this is my, as you can see on the slide number 21, that is my experimental setup. This is the GPS coordinate from where I captured the data and where I carried out my experiments. This is my experiment setup. This shows as I said earlier, the spectrometer working with the 300 to 1000 nanometer proper. So I have divided into 8 different bands, which I have listed at the bottom of the slide, from 425 nanometer to 695 nanometer. On that, I have taken the readings. I read multiple papers. From that, I identified what are the problem and what the researchers suggested the future directions. Like some of the researchers use their own data set, some of them uses the Kaggle data set. Then they have given the future research direction that the neural network will be better working, hybrid method will be effect. So this 2 slides shows the different researchers, their data, which data set they have used, which disease they have detected, and what are the future probable research direction. That I have classified into form of the different things, which techniques they have used, and their classified accuracy, which I listed here. Same way, when they have opt the deep learning approach, then which are the models they use? Some of the research use CNN, Alexa, which is 16, but almost the data set they have used, that is the Kaggle data set. And there, which I have listed also from where I take the data, that is the journal and conference name. Now I directly move to my implementation. That is my implementation methodology is I collected the raw spectra, then remove the outliers, then I calculate the spectra, and then train and test the model. And according to that, I'm going to predict it. A result shows when I just take the readings, and it is like 8 to 8 bivariant analysis I did, and then after which one is the best, that I will take it here and I'll just make it in the figurative way, so we can see that is we can easily detect the diseases, and we can classify among whether the diseases are healthy, whether it's a powder mildew or whether it's a mosaic diseases. And these are the accuracy. I applied the random forest, decision tree, and CNN models. From that, I can found that the CNN model is going to give the better accuracy compared to the other working models. And my final conclusion is that this research focus on the applicability of the spectroscopy to detect the papaya diseases, and the portable multiple spectra, which I have owned, that is there. From that, I have taken the data, and I have just taken the readings from 400 nanometer to 1000 nanometer to process the sample leads. And from this, the entire things, I can identify that VNR spectroscopy is used to detect and classify the diseases. And I applied the different models like the CNN, decision tree, random forest, and other machine learning methods also. But from that, I can find that CNN is giving the better accuracy compared to the other models. And these are the references which I have used in my paper. Thanks. This is end from my side. If you have any questions, then please.
So nice presentation. My question is that you have used CNN. Can you explain details about CNN, like how many neurons were there and how many the hidden layers, what the activation function that you have used at the output layer, likewise?
So, ma'am, actually, I have directly called the machine learning library. Sigmoid functions are there, which I use, and I just directly call the libraries from the Python, and then with use of that, I was found that the CNN is giving the 97.5% accuracy.
Okay. Have you used your own data set as you have explained? So what are the data pre-processing that you have to do before implementing the model?
I have applied the data mining methods, ma'am, to remove the outliers.
Which one?
That is the simply threshold, put the threshold, which are the like, the out of the boundaries. So I'll just remove, I'll just considering as a noise in my row spectra.
Okay, that's it from my side. Audience, any question?
So there's no question from the audience.
So I would like to thank you, Harsh sir, Gita ma'am, and the entire team for supporting us and to provide me opportunity for present my research. Thank you. Thanks.
Thank you, Hardik. Thank you. Okay, so moving for our next presenter, Sanju Kaladaran, and she's presenting on a sustainability triangle framework for digital health systems, a conceptual model for sustainable healthcare. Dear presenter, you may please start your presentation.
Am I audible?
Yes, ma'am, you are audible.
My screen is visible. And
Yes, it is.
yes. Myself, Sanju. I'm from Amrita School of Business, Amrita Vishwa Vidyapeetham, Cochin, India. And my title for today's presentation is Sustainability Triangle Framework for Digital Health Systems, a conceptual model for sustainable healthcare. And we would like to introduce our paper in a management perspective rather than a technical perspective. I hope it is an introduction slide.
Yes, it is.
Yes. So beginning with the introductions, we'll start with the Sustainable Development Goals, which was framed by United Nations in 2015 to achieve a holistic, multidimensional approach to development and sustainability by 2030, and it requires a congruence of economic efficiency, social inclusion, and environmental protection. So environmentally sustainable healthcare aims to achieving net zero emissions from the supply of health services, optimizing the environmental performance along with the efficiency of healthcare delivery. So the economic efficiency is achieved when there is a maximum value of the money spent is obtained. And the social inclusion is conceptualized as an equitable access to optimal healthcare services. So we all know that digital health or digital healthcare is gaining popularity, more popularity after the COVID-19 pandemic, as we required to consult doctors being at home at our remote places. So digital healthcare is an intersection of technology and healthcare, which has been globally implemented for achieving the SDG targets. A digital health system encompasses various interventions like telemedicine, health information through mHealth, eHealth, remote sensing and wearables, bioinformatic tools, digital platform health records, and decision supporting systems. So this is an overview of Indian digital health ecosystem. And in the first diagram, you can see who are all the stakeholders of Indian digital ecosystems. It includes policymakers, that is the central and state government. We have a digital mission at the central government, the providers and hospitals, clinics, pharmacists, labs, etc. Then other associated private entities like insurance companies, TPAs, then healthcare professionals like doctors and doctors of allopathic as well alternative medicine systems, and NGOs and administrative, which are all regulators. So ours, the architecture of our Indian digital health system is known as Unified Health Interface, in which the individual apps, like for example, eSanjeevani is a telemedicine app which enables OP consultation. This is OPD in eSanjeevani OPD app. So all these apps are individual apps which include Health Locker, that is for the storage of information and medicine records, the telemedicine, that's what I've told now, that is eSanjeevani, the CoWIN was for COVID detection, and health information management system, laboratories, etc., are conceptualized, are the individual labs, apps which are connected through APIs and other services through an unified health interface, and which are again connected to the digital registries, health records, and health claims by linking various documents like Aadhaar, UPI, ESA, and DigiLocker and consent artifact. So objective of the study is, even though we are strategically moving towards sustainability, even though the digital health systems provide better access to healthcare services to all the people in the country, there are some concerns which need to be discussed while developing this kind of information, which is mainly on social, economic, and environmental sustainability. So we try to identify various factors associated with social, economic, and environmental sustainability, and we propose a conceptual framework for the digital health system to provide us sustainable healthcare. So first, we'll move on to the economic sustainability, and it can be defined as the economy's ability to maintain itself and continue to operate without jeopardizing over time the very purpose of its existence, so that managing resources from nature and for people. So digital health services may reduce the healthcare costs caused by minimizing the transportation costs for patients and healthcare workers. But there are many costs which is involved in developing and running a digital healthcare system. So first thing that is that the sustainable funding is a key issue, and in various public health interventions, including DHS. So we propose a blended financing model to mitigate the risk associated with the economic sustainability. And what is meant by blended financing is that is an approach in which the grants and concessional capital is sourced from the public and philanthropic activities, so that the private sector also get involved in the financing of such initiatives. Most importantly, the second one is the frugal innovation. Frugal innovation is kind of strategy which is deployed in various business environments, in which the non-essential items or the non-essential features are removed to reduce the cost of that intervention. So, for example, while designing apps, frugal innovation strategies which do not provide the unnecessary features will reduce the cost of developing such applications. The second one is sustainability. That means it's a measure of human welfare, and it can be achieved by enhancing the universal health coverage, making communities self-sufficient for managing health and health promotion, targeting vulnerable population. So we all know that the digital divide in India is quite broad, and even though most of us have internet connection, a smartphone, but there are some populations which do not have access to all the services, and they include vulnerable population like the people who are living in the remote areas with less internet connectivity, and the people who are aged, who doesn't have the digital literacy, they don't know how to do it, how to use it, so that they are known as the digital determinants of health. So it includes literacy in health information and technology and access to the equipments, internet, etc. So weak technology uptake is driven by the limited exposure and confidence in using digital services and technologies. So for example, as an remedy for this, we all know that there are community healthcare workers known as ASHAs, who were used during the time of COVID to use or to help the people who are in need of an assistant to use digital health services. So such interventions can improve the social sustainability. Most importantly, the evolution of big data analytics and the digital technologies have challenged the data right and privacy of every individual. So the health locker systems or the central database may challenge the right for privacy of their own data, so which is a social sustainability challenge. And very importantly, the third one, then the last one, it is environment sustainability. As the name indicates, it's a concept, it's a conservation concept that ensures availability of services and resources to present and future generations without negatively impacting the ecosystems. So in terms of, it is conceptualized as biodiversity conservation, social needs, natural resources, regenerative capacity, limiting the use of non-renewable energy sources, waste generation, reuse and recycling. So though the DHs have a lot of positive impacts, by reducing the carbon emissions, by reducing traveling requirements, federated health record system, online appointments, ticket tracing, etc., it raises the concerns of e-waste, energy consumption, rebound effect, or systemic feedback effect. So e-waste, we all know that the computers or the servers which we are using consumes a lot of energy and finally end up as an e-waste. And finally, the rebound effect is that people, when they feel they have more access towards the healthcare services, they rapidly use the same, which causes a rebound effect by again increasing the carbon emissions. So a habit of sustainable consumption of healthcare services must be inoculated into the community to prevent to develop an environmental sustainable digital healthcare system. So we propose, by integrating all those factors, we propose a sustainability triangle framework for digital health systems. So it includes health, environmental sustainability, that is for health promotion is required, because when they have a weak health status, we are more prone to use the health systems. So we must encourage sustainable consumptions to reduce the rebound effect. There should be a cleaner production and maintenance of disposal methods, and carbon emission monitoring and evaluation in a periodic manner is very necessary while moving on to the digital era in healthcare. In the case of economic sustainability, we propose blended finance, frugal innovation, and the new business models and frameworks, financial health coverage to all the people for health, digital health, for using digital health interventions, then efficient utilization in human and technological resources with proper education, training, and implementation strategies. Unless we don't implement that, we will the strategy will result in a failure. Then social sustainability, there should be strategies to improve the health and digital literacy, should improve the internet accessibility. There should be a human assistant like Ashas, which have been explained for vulnerable populations, and device independent access, that is a centralized access should be there. And we should frame rules for the data privacy. So this is a conclusion. So we, as digital ecosystems are evolving as a strong backbone for public health system globally, it is more concentrated more on feasibility and implementation of digital health systems. So we attempted to view the sustainable digital health system through the lens of social, economic, and environmental sustainability. By the way, we all know that COVID-19 has changed the consumption practices, beliefs, and habits of global population. So while implementing innovative solutions to overcome these challenges and need in the post-COVID era, sustainability factors must also be considered. Else, the race towards the sustainability will create unsustainable products. So the proposed, we hope our proposed framework could direct the researchers and policymakers to have a sustainable strategy while implementing interventions like digital healthcare systems. So these are all the references from our side. I hope I'm here completing my presentation. Thank you.
It was nice and informative presentation. My question is that whenever we discuss about the digital health framework, then at that time there are few stakeholders that are there, like government, customers, and then the people working in healthcare. So have you done any surveying or the interviewing or some question answer to know that what are the actually requirements, what are the challenges, and what is the feasibility? So have you done anything to get to know for this?
Yes, ma'am. Actually, we had done a study in 2021 during the second phase of COVID regarding this e-Sanjeevani app. So we tried we attempted to use the health belief model and theory of planned behavior to understand why people are using and why people are not using the app. So that was a first study from our side to understand the perceptions of the public. for using the digital health interventions like e-Sanjeevani, because we all know that in near future we might shift to a to the digital health in a full-on manner. So we tried doing that, but we are on the research process. Like we are just in the beginning stage. We are planning to proceed with taking the perceptions of various stakeholders, and we'll be doing it in another year or two.
Yes, as you need to take a stakeholders as the people are using and people who are going to develop. So blend of everything, all requirements, then that framework can be the robust one. So it was nice presentation. That's it from my side. Audience, any question?
Thank you, Gitanjali ma'am, and thank you, SMARTCOM, for giving me an opportunity to present it. And wish you all have a great day ahead.
Thank you.
Okay. Thank you so much, ma'am, for your great presentation. Ma'am, we have to wait for 5 minutes. There are 3 participants who are absent. We have to wait for them. They will join us in 5 minutes. Then we have to complete the presentation. Otherwise, we have completed the presentation.
Okay, no problem. We can wait.
Okay. Okay. Is there anyone who presenting the paper of the escalation sound classification era of the future? Okay, so there is no one. Okay. So to conclude this session, I sincerely thank our authors for their excellent presentation and their great contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for your support during this version and the previous 6 version of this conference. And we will be happy to have you all in the 8th version of this conference in 2024. Moreover, all the participants will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the springer. And the publication will be live within 5 to 6 months. So kindly cooperate with Team SMARTCOM 2023 and the Global Knowledge Research Foundation. Just before we end the session, I would like to thank our session chair for chairing the session. Ma'am, there's a token of appreciation to the chair on behalf of Global Knowledge Research Foundation and their Team SMARTCOM 2023.
Thank you, Harsh. Thank you very much for giving me opportunity. And it was a very informative session. New insights we get from all these various domains. I wish all the best for all the participants. Keep working and keep doing research. Thank you.
Thank you, ma'am. Thank you for your valuable presence over here. Now, in the end, I would like to request you all to turn on your camera to capture the good memories of this virtual conference. Thank you all.
Thank you.
Thank you, sir. Thank you, ma'am.
Thank you.
Thank you, Gitanjali ma'am, once again.
Thank you. Thank you. May I leave?
Yes, ma'am. You can, please.
Okay.
To all the authors, stay safe and take care.